Yeah. Okay. Action.
Assalamualaikum warahmatullahi wabarakatuh.
Assalamualaikum warahmatullahi wabarakatuh. Bismillahirrahmanirrahim. Allahumma aftah alaina hikmaka wa yassir alaina min khaza'in rahmatika ya arhamar rahimin. Rabbi shrah li sadri wa yassir li amri wahlul 'uqdatam min lisani yafqahu qawli.
Okay, you may sit down. Okay, so how are you? Good? Masya okay? Everything okay? Alright, so everyone okay? So before we proceed with our lesson, as usual, I want to take your attendance. So ada nama Nisa? Aina Madia? Cikgu Medina? Ibu Tini? Usha? Abi Hank? Abu Afan? Aidan Zafri? Arif? Danish Bayu? Sikri? Ilham Hakimi? Eka? Zafri Rahim? Iris Bizani? Syahirah Najihah? Putri Kasih? Putri Kasrina? Sofia Ramadan? Yashila? Zalim Marisa? Okay. So everyone is here. Good. Okay. So you may open up your textbook. So today we are going to focus on 2.7, which is about impulse and impulsive force. Okay. 2.7, chapter 4. Alright, so in the picture that you just see in the screen, what can relate the phenomenon of the impulse and impulsive force? Do you have any idea about impact? What kind of impact? Impact in a short period of time, and then the impact of impulsive force. Impulsive force. So higher impulsive force will give the higher impact. So these two pictures will give the application phenomenon about impulse and impulsive force. So today's lesson, we are going to focus on these 4 topics, 4 key points. Okay, so first one, we are going to learn about what is actually impulse, so the definition of impulse. And then number 2, we will try to relate impulse to change in momentum. Okay, and then number 3, calculate. We are going to do some calculation on impulse and impulsive force, and we are going to explain the effect of time of impact. Effect of time of impact. Okay, so first one, let's define impulse. So let's get to know what is actually impulse. So by referring to your textbook, can you tell me what is the definition of impulse, class? Product of force and time. So what is the formula of impulse? J equals to Ft. So take note, the formula for impulse is J equals to Ft. Right? So let's label them up. So what is J? J is impulse. Okay. Impulse. Take note. And then F? Impulsive force. Okay, impulsive force. And then lastly T. So what is T? Time of impact. Right? So the formula for impulse that you need to remember is J equals to Ft. It is really that simple. Okay, and then the unit for impulse, Ns. Okay, Ns. So N is N is Newton. Okay? And then S is second. So Newton second. It comes from the formula. F is N and then T is second. So when we multiply them together, we will get NS. So that is the unit for impulse. And lastly, the fourth point for impulse is you need to know that the impulse is actually a vector quantity. Okay? So the vector quantity, what is the difference between scalar and vector quantity? Ayman Mardiah? Difference between scalar quantity and vector quantity. Vector and direction. Okay, good. Right? Okay. So that's the difference. Vector quantity, we have two values, magnitude and direction. Okay. Right. Okay, so next. So far, define definition of impulse. Any question? Okay, I will give you the facts first, and then we will try to do a few questions. Okay. So define the definition of impulse. Check. And then second point, we want to relate the impulse to change in momentum. Okay. So another definition for impulse is the change in momentum. So another formula for impulse is J equals to change of P. So I want you guys to remember this. Okay. So far we have two formula for impulse. What are they? Discuss. Come on. J is FT. J equals to change of P. P stands for momentum. So remember, J equals to Ft and J equals to change in momentum. So change in momentum, to further elaborate, is this formula. J equals to mv minus mu. So, as we learned in the previous class, momentum, the formula for momentum is mv. So change in momentum, mv minus mu. Okay, so far we right, that's okay? Okay? Alright, so next one. So second point, okay, last okay, the third point, impulsive force. So what is actually impulsive force? Impulsive force is the force acting in short time. Okay, impulsive force is the force acting in short time. Basically it's the formula, it comes from the formula J to Ft and then the value of F inside. So what is the value of F in the formula of impulse? So that is the impulsive force. So in order to derive, to get the value of F from the formula of J equals to Ft. Okay. So we need to get the value of F. So how do we get F? So basically we derive E, we bring to the left side. And then we will get J over T equals to F. So F equals to J over T. So G, because that another formula for G is mv minus mu. So mv minus mu over with T. So this is the final formula for impulsive force. So if you encounter with the questions that ask you to get and to get the value of F, which is the impulsive force, so this is the formula that you need to use. So the origin, before we get this formula, that's the process. It comes from the J is equal to Ft, and then we derive it out, we will get the value of F. Okay, so far we have go through 3 key points in this chapter. So definition of impulse, and then the relationship between impulse and change in momentum, and then we will try to complete the force and impulsive force. Okay, so the formula is given. Alright, so let's do some activity just to make you engage and understand more with the formula. Okay, so this is the individual solo activity. So I want you to clap fast as possible. Okay? Okay. The impulsive force will be lower. Right. I get that. Time of impact. So the time of impact plays a very important or critical role in this phenomenon. Okay? So when you have a lower time of impact or faster, it will give higher impulsive force. If the time of impact is longer, the impulsive force will be lower. Okay? Understand? Okay, again. Right, so second activity. Work with your friend. Besides you. Work impact. High five challenge. Okay, so first, high five as fast as possible. I don't need that, don't need the white face. Okay, first, fast as possible. Okay, second one, as slow as possible. As slow as possible. Okay. So, what can you conclude from these two activities? Faster or lower time of impact will give higher impulsive force. Longer time of impact will give lower impulsive force. Okay? Clear? Alright. So that's the formula and that's the facts and the concept that you need to understand in this topic. So let's do some questions. Okay? So these are the key points from our activity just now. So effect of time of impact. So the time of impact plays a critical role in order to determine the value of force. So shorter time, large impulsive force. Longer time, small impulsive force. Okay, so I want to relate these points with the picture just now. So Cristiano Ronaldo, you know that? Yes. Alright, so when he kicks the ball, time of impact, fast or slow? Fast. Okay. So the impulsive force will be higher. So look at Ronaldo. And then second picture, the time of impact, which one? Longer or faster? Time of impact, slower or fast? So with the application of airbag, fast, sure. And then can you hear slower, because without airbag, his head will hit the steering fast. Sure. Okay. So in order to prevent that, airbag will be coming out, and then it reduces or make the time of impact lower, slow, so compared to without airbag. Okay. So how can we do it? Right? Okay. Alright, so let's do one question, and then let's do this together, and then I will give a set of questions just to test yourself. So example 1, let's do this together. A plasticine ball of mass 0.058 kg is thrown towards a wall with a velocity of 10 meters per second. The ball hits the wall and comes to rest, sticks to the wall. Calculate the impulse experienced by the plasticine ball. So class, impulse. So what is the symbol for impulse, class? J. Okay, good. J. Right. So what is the formula that we can use? Since we have two formula for J, so the MV minus MU. Okay, good. MV minus MU. So J equals to MV minus MU. Okay. Since J is the change of momentum. So mass of the ball is 0.058 times with final velocity. Final velocity, what is the value? Final velocity plus 0. Because comes to the rest. So this is the keyword. Comes to the rest, meaning it will become stationary. So finally it will have the velocity of 0. And then minus with 0.058 times with initial velocity is 10. Okay, can someone calculate for me? Negative 0.58. Okay, negative 0.58, and the unit for impulse ns. Okay. ns. So far, any question? Clear? Okay, so test yourself. I give you about 5 minutes, and then I want one of you to share your answer with the class. Okay? Same concept. Just be careful with the negative and positive sign. So in this question, it rebounds. So when it rebounds and move in opposite direction, meaning the sign will be negative or positive? Negative. Okay, negative. Then for C, I need one here. The direction of the impulse. Direction. Okay. Symbol for change in momentum, delta P. Class be careful, negative 8. The vector of velocity will be negative. Negative 8. Why? Because the velocity final is opposite direction from the initial velocity. So be careful. So 0.06 times with negative 8 and then minus 8. 0.06 times 5. Good. And then continue with B. So once we have gained or obtained the value of change in momentum, so basically indirectly you obtain the value of J. So J equals to yes, because the formula is J equals to change in momentum. J equals to 1.2 yes. Negative. Okay, good. Right. So everyone, do you have any question? If you have, if you're okay, wrong, answer. Okay. So why? Because the value of final velocity it should be a little bit. So you need to be aware when it is opposite direction. So the value or the negative, the sign will be negative. Okay, for C. Okay, boleh. Right class, so for C, the direction of the impulse is opposite. Opposite to the direction of the initial motion. Oppo. Okay, thank you for your participation. Okay, so C, the direction of the impulse is opposite. So why opposite? Negative. And it bounces, right? Okay. So any question before we proceed with the next question? Any question? Yeah? Okay, good. Alright, so copy the answer first before we proceed. Okay, so next question. Let's do this together. For example, a golfer strikes a golf ball of mass 45.93 grams, and then the ball moves off with a velocity of 50 meters per second from rest. At the time of contact between the club and the ball is 0.05 seconds. Calculate the impulsive force. So class, what is the symbol for impulsive force? What's that? Yeah? F. So F. So before you try to answer, identify which value that you include. Okay, so impulsive force, highlight, and then highlight the symbol. Okay, so that it will be clear. So from the formula J equals to Ft, so we need to find the value of F. So how? F equals to J over T. Next, J equals to mv minus mu over time of impact. Okay, class? Okay. Let's substitute the value. So M, okay, before we substitute the value, you need to make sure every single value is in SI unit. So G, is it in SI unit? So what is the SI unit for mass? kg, okay? So kg must be divided by 1000. So 1, 2, 3. So 0.046 kg. Okay, that's round off. 0.046 kg. And then the velocity, is it in SI unit? Yes, meter per second. So we don't have to convert any longer. So m 0.046, and then the final velocity. What is the value for final velocity? 50. And then minus with m, which is 0.046. Then minus with the initial velocity. So what is the value of initial velocity? 0. Why? Why 0? Because from the rest. So originally it is stationary. It is at rest. So no velocity. So 0. Then divide by t. T is 0.005 seconds. So can someone calculate this for me? I don't have any calculator. 459.3. So the unit for force class, what is the unit? N. So N. Okay. Any question? Okay, so far clear? Okay, so if you are clear, test yourself. Okay, 5 minutes, and then I will some random of you to share the answer. Cinta. Cinta Medina. Awak kan? You B. Okay. If you have any question, you may ask me, ask your friend. I want you guys to copy the questions and then answer. So that it can be a contact time is 0.0004 seconds. Okay, that's it. 0.0004. Cinta Medina. Class, before you proceed with anything, you need to write the formula first. Okay? Write the formula of impulse first, and then you will proceed with the next step. Because the formula will give you 1 mark. Okay, you forget to write your formula first. Okay, class. Did you get the same value? So yes, correct. Okay, good. So the first one write the formula, J is to MB minus MU. And then substitute the formula, make sure the value is in a SI unit. Then you will get 2 Newton seconds. So that is the response. Okay. Alright, so next one. B. Kushal. Seems very active. Calculate the impulsive force. Okay, Kushal. So class, the symbol for impulsive force is F. Okay, F. B. Okay. Okay, class. So you get 500 Newton.
Yeah.
Okay. So, extra one. Okay, F equals to J over with T. So from the original formula, J equals to Ft. So you derive. You get F equals to J over T. So J is, just recycle the value you obtained earlier. So 2 over 0.04. Then you get 500 Newton. Can you okay? 500 liters. Okay? So far so good. So far clear. Any question? No. Okay. Good. So far we have complete with 4 key points. Alright. So definition for impulse. Can you repeat? What is impulse, class? And then the symbol for impulse. What is the symbol? J. Then second point. Another formula for impulse is J equals to change in momentum. Okay? Change in momentum. And then the third point, you need to find the impulsive force. So how do we find impulsive force? Plus F equals to J over T. Okay? And then you need to know how to explain the effect of time of impact. So with higher or longer time of impact, smaller force. Okay? Question? Okay? With faster time of impact or lower time of impact, fast, the impulsive force will be large, higher. Okay? Alright. Okay, so last but not least, application. So application of impulse and impulsive force, this topic to the airbags. So since we have known this knowledge about this term, we can actually prevent accidents by using airbags. Okay, I want to ask you, the airbags, function of airbags is to increase or decrease the time of impact? Decrease the time of impact. So that the impulsive force will be lower. Will be lower. So that will be safer. Okay, good. Right. Same goes to helmets and same goes to safety nets. Okay. Function to increase the time of impact. Increase the T. Increase the T so that F will be lower or decrease. Okay. So, any question before we end our class? Okay, good. Alright, so that's all for today. Thank you, everyone. Okay. Before you exit the class, I will check your Okay, thank you guys.
Thank you, sir.
Okay, thank you. You all.